Why, with Project Lyra, intercepting Oumuamua might be within reach. In 2017, astronomers spotted Oumuamua. It was unlike anything we'd ever seen hurtling through the vast void of space. This object was moving 3 times faster than the average comet in the solar system. Its speed, shape, and path were strange. But with the object now over 6 billion kilometers away, the mystery remains unsolved. Some scientists think it's worth chasing it. But is it feasible with such a vast distance to cover? What would it take to catch up with Oumuamua? And where are we on that mission? Let's find out. On October 19, 2017, the University of Hawaii's Pan-STARRS 1 telescope made a discovery that would spark years of fascination and debate. While scanning the skies for near-Earth objects, it detected a strange visitor from deep space, labeled 1I 2017 U1. Later, it was nicknamed Oumuamua, meaning a messenger from afar arriving first, in Hawaiian. It wasn't just another asteroid or comet. It was something entirely unprecedented. Oumuamua stood out immediately for its speed. It was over 314,000 kilometers per hour, much faster than typical solar system objects. On September 9, 2017, Oumuamua reached its closest point to the Sun, zooming past at a jaw-dropping 87 kilometers per second. So far, normal for a visitor from the stars. But something bizarre happened when it started heading back into space. It didn't slow down like it should have. Initially, astronomers thought it might be an asteroid, as it lacked the gas and dust trails that characterize comets. Instead, it suddenly accelerated, as if defying the sun's gravity. However, no signs of outgassing were detected. No coma, no tail, and no gas clouds. Astronomers estimate it to be somewhere between 100 and 1,000 meters long, with a shape resembling either a disk or a cigar. But what took Oumuamua from an interesting observation to a full-blown cosmic mystery was its strange behavior when it passed by the Sun. It deviated from the path predicted by gravitational forces. This means that gravity was not the only thing dictating its path. Detailed observations revealed that Oumuamua's brightness fluctuated dramatically every 7 hours, suggesting it was spinning or tumbling around its axis. These variations led researchers to conclude it had a highly elongated shape, roughly 10 times longer than it was wide. The shape was unlike anything seen in space before. Rob Warwick, the researcher credited with its discovery, noted, its motion could not be explained using a normal solar system asteroid or comet orbit. This motion and its interstellar origin, confirmed as the first of its kind ever observed, solidified its place as one of astronomy's greatest mysteries. While astronomers believe such interstellar objects pass through our solar system about once a year, they are usually too small or faint to detect. Oumuamua, however, was a rare glimpse into the unknown. It carried clues about distant celestial bodies. Speculation about Oumuamua's nature has ranged widely. Some suggest a strange asteroid or a fragment of a shattered planet. Others speculate it might be an artificial object. Alright, before we dive into the widely accepted science behind this intriguing visitor, let's quickly check out why lots of people think Oumuamua might be linked to aliens. To do that, I must introduce you to this guy, Professor Avi Loeb. So in October of 2018, Avi Loeb and his colleague Dr. Shmuel Bialy came up with a bold theory about Oumuamua's weird behavior, particularly its unexpected acceleration. After going through peer review, their study was published in the astrophysical journal Letters, but not everyone was on board with their ideas. Bialy and Loeb suggested that Oumuamua's strange acceleration might be explained by its shape and surface. They argued it could be thin and flat like a pancake or even a light sail, or a reflective surface that could be pushed by solar radiation. According to their theory, the Sun might have given Oumuamua the extra speed and odd trajectory we observed. What's more, the way it entered our solar system and zipped past Earth after swinging by the Sun seemed almost like something you'd expect from a purposeful interstellar explorer. Of course, this idea stirred up plenty of debate. Some media outlets ran wild with the theory, claiming Bialy and Loeb were suggesting Oumuamua was an alien probe. On the flip side, skeptics were quick to shut down the idea, questioning why a respected scientist like Loeb would even entertain something they saw as far-fetched. So, what do scientists generally agree on? Where did Oumuamua come from? To figure out where Oumuamua came from, astronomers traced its path back through millions of years. It looks like it came from the direction of Vega, a bright star in the Lyra constellation. They've narrowed down 4 possible stars it could have come from, some as far as 81 light-years away. But so far, there's no definite answer about its origin. Now, it's over 6 billion kilometers from us, zooming through space at 26 kilometers per second towards the Pegasus constellation. For context, that's about as far as Voyager 1 was when it captured the famous pale blue dot photo. Even if Oumuamua isn't some alien spacecraft, it's still a big deal because it's the first confirmed interstellar object to visit our solar system. Naturally, scientists wanted a closer look. We first spotted it 40 days after it zipped past the Sun, but then it was already 33 million kilometers away from Earth. Ground and space telescopes immediately went into high gear, trying to learn as much as possible before it got too far. Unfortunately, by mid-December, just 2 months later, it had become too faint and fast-moving for even the most powerful telescopes to track. With limited data and more questions than answers, some researchers believe the only way to learn more is by chasing it down with a spacecraft. But catching Oumuamua is no easy task. First, there's the challenge of speed. At 26 kilometers per second and already over 6 billion kilometers away, no current chemical rocket could reach it fast enough. Second, even if we catch up, we need to slow down to study it. If we're going too fast, we'll just fly past without gathering useful data. Finally, it's incredibly hard to find something so small in the vastness of space. Oumuamua is only about 1,000 meters long, tumbling through interstellar space like a cosmic needle in a haystack. But obviously, scientists aren't ones to give up like that. There's been a lot of hype in the science world about tracking down this interstellar visitor. The big question is, where are we in the hunt for Oumuamua? Although reaching Oumuamua is incredibly challenging because of the distance between it and us, the technical hurdles, and the difficulty of spotting it in the first place. However, research groups haven't given up on finding ways to make it happen. While getting a spacecraft to accelerate fast enough to catch Oumuamua is no small feat, it's possible by using gravity assistance from nearby planets. One well-known proposal comes from Project Lyra, an effort by the Initiative for Interstellar Studies. They've outlined 2 potential trajectories for sending a probe. The first plan involves 3 key velocity changes. First, the probe would be launched from Earth's orbit and directed towards Jupiter. Once it reaches Jupiter, the probe would slow down enough to fall towards the Sun. This maneuver takes less energy than starting from Earth because Jupiter's orbital speed is less than half that of Earth's. As the probe approaches the Sun, it reaches its maximum speed. At this critical moment, rocket engines fire to give it a huge boost, maximizing acceleration with minimal fuel use, a technique known as a solar O-berth maneuver. Using this approach, researchers estimate the probe could exit the solar system at over 70 kilometers per second, which is fast enough to catch Oumuamua. However, this plan isn't without challenges. First, a close approach to the Sun would require a heat shield to protect the spacecraft. Fortunately, this technology already exists. The Parker Solar Probe uses a similar shield. Unfortunately, the shield's weight, 72.5 kilograms, limits how much equipment the spacecraft can carry. Additionally, this route involves a long trajectory, sending the probe from Earth to Jupiter, towards the Sun, and back out past Jupiter again. A shorter path is theoretically possible, but it's tricky. Lastly, this mission relies on advanced maneuvers that haven't been tested in real space missions, giving it a low technology readiness level. In other words, while it's doable, it would be incredibly difficult to pull off. So there's actually another way we could catch up to Oumuamua. The second plan from Project Lyra goes like this: launch from Earth, swing around Venus and Earth, do a deep space maneuver to change our probe's direction, then swing by Earth again, and finally use a gravity assist from Jupiter to fling our craft towards Oumuamua. This plan skips the need for a heat shield, takes a shorter route, and means our probe will be moving slower as it heads into interstellar space. That'll make it easier to slow down when we get close to Oumuamua, allowing us to gather better data. Project Lyra has already spotted at least 2 solid mission options with launch windows between 2030 and 2033, aiming to arrive at Oumuamua in 2048. One of the mission designers, Marshall Eubanks, thinks a mission to Oumuamua is pretty much inevitable. After all, researchers are working on proposals for missions to other solar systems. But even a century from now, Oumuamua will still be a lot closer than those far-off places. But here's a thought. What if we could have seen Oumuamua coming months ahead of time instead of just after it zipped by? Astrobiologist Karen Meach from the University of Hawaii, who helped analyze Oumuamua after it was discovered, believes we'll soon be able to do this for other interstellar visitors. NASA thinks we get an interstellar object like Oumuamua passing through our solar system about once a year. The tricky part is that they're tiny, making them tough to spot, until now. The Vera C. Rubin telescope, set to start up in 2025, will be able to detect these objects a full 3 months earlier than the telescope that saw Oumuamua. Plus, it's going to kick off the Legacy Survey of Space and Time, LSST, which will create a massive database of 2 million images over 10 years. This data will be perfect for spotting changes in the night sky, like the paths of comets and asteroids. A paper from 2023 estimated that the LSST could find up to 70 Oumuamua-like objects each year. There's also the ESA Comet Interceptor mission, launching in 2029. This mission will park a probe in space for up to 3 years, just waiting for a comet or interstellar object to cruise by. When the time is right, it'll spring into action and do a close flyby to create a 3D map of the object. It's the first mission ever aimed at an unknown target. Unfortunately, we don't know how long we'd have to wait for another object like that to show up. It'd be a huge waste of time, energy, and money if we didn't get another Oumuamua-like visitor in that window. Plus, these new methods won't give us any fresh data on Oumuamua itself, which is now too far away for our telescopes to reach. If we just sit around waiting for another one, we might lose whatever answers Oumuamua could have provided, lost in the vastness of interstellar space. What's next? And is this object wasting our tax dollars? The future for hunting down and studying these interstellar objects is certainly an intriguing one, but whether it's worth the hefty price tag is up for debate. On one hand, the technical capabilities are there. We've got solid mission plans from Project Lyra to potentially catch up to Oumuamua, and new telescopes and surveys coming online that could spot these elusive cosmic travelers way ahead of time. But on the other hand, space missions are some of the most resource-intensive undertakings humanity pursues. We're talking lots of cash, years of complex planning, massive teams of brilliant minds, and mind-boggling engineering challenges. Is chasing down Oumuamua or its successors really the best use of all those precious tax dollars and scientific brainpower? Interstellar objects will keep passing through our cosmic neighborhood. If it happened with Oumuamua, it's likely to happen again. Do we need to act on every sighting, or can we wait for better opportunities? Still, the allure is strong. What if Oumuamua is an alien artifact? Such a discovery could transform our understanding of existence. It's a gamble, but one researchers continue to weigh. And that's a wrap for today. But don't worry, that was just the tip of the iceberg when it comes to fascinating science discoveries. Sure, I said Oumuamua flew past us, but I left out that there's a massive object on a collision course with Earth in a few years. To find out more, check out our video on Apophis, the asteroid that could hit Earth in 2029. Trust me, you don't want to miss it. Click the link right here to watch now. Thanks for watching.